guess Stu here. This video I'm going to be looking at a situation where an outboard's not starting and not turning over. So it doesn't cover a situation where the motor's turning over, it's actually not firing. We'll do that in a separate video. So this video is a situation where you kind of turn the key and nothing's happening at all. So I originally was going to do this video on adding a push start to this particular little outboard, but I've decided to sort of expand it to this whole situation because I've actually had this problem with my own boat yesterday and a few other boats. So this video is a little bit choppy in that you'll see it's day, night, you know, recorded over different days, but I decided to try and just pull it all together in one video to show all the different reasons why you might be having this problem to help people sort of diagnose it. So let's get started, and we'll sort of start with the easier, more obvious stuff you should check first, and then we'll move right down to sort of things like putting new brushes in and out in the starter motor if it's gone. So I hope you enjoy, and I hope you're having this problem, it helps you solve it.
The first thing I'd always check when you've got this situation is the boat in neutral. Later on we'll go through testing the switch that stops it starting in gear. That switch can be faulty as well, and in fact this outboard had a faulty switch in it, so we'll see that. But if a boat's in gear, particularly with with this one, if it's it's actually got the switch inside the outboard, which is one we're going to be testing, but also if it's a forward control, the switch is actually inside the forward control unit, so you can open that up and check that switch there too. But if it's just in gear, and sometimes it's only just a little bit out of gear, it looks like it's rocked back but it hasn't actually clicked in, and that's all it could be. So just make sure, rock it back and forwards, make sure it's actually in neutral. You might be able to turn the key or push the button or whatever it is, and it'll start just fine. So that's a nice simple thing, sometimes it is just that. The little lanyard that you pull out from the sort of dead man switch won't stop it turning over generally. It just earths out the ignition, so it can't charge, so it will crank but not start. But this video we're focusing on just actually not cranking over, or not turning over. So that's not going to be a problem, but it is the other switch, which is I'm not quite sure what they call it. There's an isolation switch. It's basically starting gear protection. So check that one first. The next thing after that I'd look at is just the battery. Is the battery gone flat? You know, I'm sure everyone's pretty familiar with that. It's a pretty standard concept. I am going to do another video on testing batteries because there is a bit more to it than you might think or like, certainly like I think, you can put a multimeter on a battery and it's got 12 point something volts. But as soon as you turn the key, if that voltage really drops, the battery's not good. And that's kind of what they call a load test. You can get load testers, but the newer ones are actually these capacitive testers that somehow test the capacitance of the plates, which gives you a really good indication of the health. So I'll go through the different ways to test a motor, but really, if you put your multimeter on your battery, it's showing the voltage, and when you turn the key, that voltage really drops down, you know, well below like sort of 7 volts or whatever. You know you really got a battery issue as well. So don't just put a multimeter on a battery standing by itself and consider that to be a good battery. So they're the kind of obvious two things: battery and not being in gear. And then beyond that, you're really looking at some more sort of mechanical fault situations. So let's now go to this motor. I've already filmed this bit and it was night time, so sorry, this video is a bit, you know, all over the place, but I am trying to bring it all together in one sort of cohesive diagnosis video, as opposed to just being about doing this one job. So we'll have a look now, and once you know you've got good battery and it's in gear, we'll start testing what bits of the system can fail to mean that it's not turning over.
So here we've got a starter motor, obviously, and they've got the starter solenoid here, and then comes down here to what's obviously some sort of starting gear protection. So when it's in neutral, this contacts this switch, so if it's in either forward or reverse, it's not. By the look of that, it's barely grazing that switch. It does seem to push it in. So I'm just going to start by seeing whether we can get the solenoid to click at all, get some continuity. So I'm actually just going to take these pieces out so we can look at them one by one. So I'll just pull them out on the bench, we'll test them all individually, and then hopefully once they're all working, we'll sort of pop back in the boat. Sorry, I was getting a bit carried away there and just pulling it off, but I thought you'd probably be interested. So starter motor generally has 4 bolts. You'll have 2 at the top here, and then 1 down the bottom here you can see sticking out with the long head on it. The bottom's generally just a groove that sits on there where these ones come through, and the whole body of the starter motor is ground, so you'll generally have a ground lead attached to one of these top 2 nuts. So I've just taken the ground lead off this one that just had another nut holding it on, and now I'm going to remove these 3 bolts to take it out.
Don't worry, it's just water, I'm not that much of an alco. I finished the gin this morning. So we talked a bit before about how the negative, or the ground, comes to the case of the motor, and then down here we got the positive lead. It's a bit deceptive in it sort of looks like you've got this metal casing with ground and positive 12 volts sort of attached at once. But this washer in here is actually an insulating washer, and then inside the casing there's an insulating tube this bolt goes through. So this particular bolt doesn't actually have conductivity between the bolt and the casing in any way. It goes straight to a couple of the bushes inside. So we'll have a look when we take one of these apart. So we could actually just jump straight to checking if this starter motor works at all by putting a bit of power on it. So these are just a set of jumper leads attached to a car battery on the other end of the bench. So I'm just going to put the ground onto the body of the starter motor and then onto the positive. Okay, so good start, this seems alright. I actually do have a starter motor over there that's not working at all from memory. Just a little one out of a smaller Yamaha. Yeah. So we'll pull this one apart. So far we know this works. I probably didn't have to take it out to do this, obviously. This isn't quite how you go about this job, but for the purposes of showing. So next thing I'm going to pull out is the solenoid. So this solenoid's a bit dirty, but ultimately what it is a mechanical switch. Now, solenoids are a bit like relays, transistors, all that sort of thing. The fundamental idea, let me get a bit of paper. So, the way a solenoid works is essentially it's a unit. And there's a sort of electromagnet in it. And then this magnet, when it activates, it sort of pushes a little rod, which then connects another 2 wires. So this is sort of a switch sort of arrangement. So the idea is that a large current flows through this circuit, but it doesn't flow if it's open. And then if a current, like a smaller current, flows through this circuit, it turns this one on. So it's like a switch, but instead of flicking it with the hands, you flick the switch on by letting electricity pass through it. So 2 small wires, 2 large wires. And this is what it looks like on the boat. These 2 terminals here are the 2 large wires, the ones that are off, and these are the 2 small wires. So when current flows through this circuit, current is allowed to flow from here across to here. These 2 are joined. Now the reason you do that is pretty simply because you generally want a key or some sort of control at the driving position of the boat, and starter motors take a lot of current, so it's pretty easy to pass that small signal current all the way to the front of the boat, have it run through a small key mechanism, but you can't pass this large current that you need to start the motor all that distance. So you're keeping it a very short distance that the big current's flowing, and then having this short sort of low current signal being the one that travels the distance. So that's why these things exist. Okay, so what we're going to do is we're going to test this first. We've already tested the starter motor, so we know that works. Now let's see if this solenoid works. So the way I'm going to do that is I've just got this multimeter set up to an audible continuity test. So I've got the positive and negative E, so there's a common, then there's an ohm setting here, which is a measure of resistance. So continuity, essentially, you're testing resistance. So an open circuit has sort of infinite resistance, and a closed circuit has almost no resistance. And that's what I'd expect to see through here. So the leads themselves will put together a bit of resistance. So saying like 9 ohms, I think it is coming through the cables. So what we're going to do is, now these are the two terminals we're expecting to be joined. So if I connect to here and here, we're not getting that continuity beat because currently that circuit's open, that switch is off. But we expect that switch to come on when current's flowing through here. So I'm just going to use my little 12 volts power supply. The other big thing is you'll hear these. So as soon as I connect it, you hear it click, and that click is actually that magnet activating the mechanism to connect this. But that doesn't actually guarantee we're getting any current through, but we are like that. So if I disconnect this, so you can hold this all at once. So as soon as I've disconnected power from these two wires, this circuit closes. So while you turn your key, what you're actually doing is sending current through these two wires, turning the switch, starting the starter motor. So we know the solenoid's good. Actually, what I will do again, sorry, is just put it back on. So it's got 18 ohms of resistance through it. I'm not quite sure what the spec is, but to me, given my cables alone were giving me 9, I reckon that's pretty good. If you were getting, putting your power on, hearing this click, you're getting a really high resistance across here, you might consider it still a faulty switch or a faulty solenoid. But so far we've got a good starter motor and a good solenoid, so good start. So the third piece of this puzzle is this starting gear protection switch. So it sits in the boat, and as I was sort of trying to show you, I'm not sure how clear you could see it on the boat. If the boat's in neutral, the little lever was pressing against this switch. If it was in forward or reverse, it wasn't. So what that tells me is I'm expecting, because you want the boat to start in neutral, and the way this was connected in series, that the idea is this is actually a second switch, so only when this switch is on and this electric switch of the solenoid is on will the starter motor go. So I'm just going to test this switch now, and this one, once again, all we're looking for is continuity when this switch is on. So as far as I can tell, this switch is faulty. It's never actually coming on. And so what that means is that you'd turn the key. In this case, well, there's actually not even a button on it, so we're going to have to install something like that as well. But you would turn the key, press the button, whatever it is, you would be trying to supply power to this circuit, but it wouldn't be reaching, so you wouldn't even be hearing your solenoid clicking. So you might kind of jump to the conclusion that you're not hearing that solenoid click, it's a faulty solenoid. In this case, it would have actually been this starting gear protection. The other part of this electrical system is the kill switch that you're probably all pretty familiar with. But bear in mind, this won't stop the starter motor turning over, it'll only stop the ignition system firing. So you can still turn the motor over if that switch was faulty, but you just wouldn't be getting any spark. So I'm not going to worry about that too much. I'm more worried about just getting this working. So I need to find another one of these. You obviously could just short this out and not have any starting gear protection. Don't recommend it. You know, obviously it can be pretty dangerous. I've seen people fall out of boats. One guy I saw actually hit the gunnel on the way out and broke his pelvis sort of thing, so it could have been really, well, it was nasty, but it could have been fatal. So try to avoid the temptation just to short this sort of thing out. It's not worth it, it's just a switch. You know, I'm sure you can get one second hand from a wreckers or something for not too much money. So one last thing I'm going to, well, I say last, I'm filming this last, I have no idea where this is going to go in the video. One other thing I'm going to show you is I'll take apart this forward control, because we looked at the tiller outboard behind me, and it's got that neutral switch under the cowling. But with forward controls, it's generally inside the forward control unit itself. I haven't had one of these. This is actually from a Tohatsu 40C. Haven't had one of these apart for about 10 years, but I'll crack it open. I can't recall what they're like inside. We'll have a look, and I'll show you the switch if it's in here. Otherwise, I have to find a Yamaha one to show you. So if you are taking these apart, generally it's to attach these push-pull cables for the steering, for gear and throttle. So be aware for those. You only have to take these two screws off to get the lower plate. So, oh yeah, here we go. This is very similar. I imagine most outboards are the same. So I'll just bring the camera down here and I'll show you the switch I'm talking about. So here's the switch in the forward controls. So this serves the exact same purpose as the other switch, which is probably still lying around. Oh no, I think I took it actually. The other switch we saw under the cowling of the tiller steer. So when the boat, so I'm going to hold this, sorry, when the boat goes into neutral, it pushes this little switch in here and allows the starter motor to go. So if this switch is broken, like the other one was, you'll have the exact same problem. So what we're looking at here is the starting system circuit diagram from the service manual. This is actually from the boat I've got, that Yamaha. What we're looking at here is all the various components: battery, starter motor, solenoid, etc. What we'll find here is that then goes through this 10-pin plug, and this is now a long cable that runs up to the forward controls, and these are the switches, and these are talking that when it's off, white and brown's connected, when the ignition on, the red and what's P? They don't say. This is the colour code, and they've got, I don't know, pink actually rings a bell. Is connected, and then the red, pink, and then brown is momentarily connected while it's starting. So when the red and brown's connected. But the fault I had, as it turned out, was that I had this red lead. I got 12 volts or 12.9 volts or something on the pin here. The red's actually this top pin just above the gap. Hang on, I'll get something other than my big fat finger. So this red pin here is where the 12 volt comes to the forward to controls. I had 12 volts at the output pin on the outboard, but by the time it got to this pin at the other end, it dropped to sort of 9 volts. There was obviously an issue with the cable there. So I ended up just putting a lead on the battery and running a fresh 12 volt wire right up to the forward control, and that totally fixed my problem. So what it meant is I was turning the key, it was connecting red to brown, it was coming back, but that current coming back wasn't enough to activate this solenoid. So the solenoid you saw before in this video, different boat, but that solenoid was working in my boat, but the input voltage wasn't enough to trigger it to switch on and send the main voltage to the starter motor. So I'm going to be heading down to the boat later, but I'll splice in a bit of a video and show you exactly what that looks like on that 50 horsepower. So on this boat, this is the main battery lead that comes up to this start relay here, and you can see a couple of leads come off there. So this is just a direct feed that's constant power, so battery's always supplying power to this terminal, and it comes off here. Now this lead here, sorry, I hope you can see that. I can't actually see the viewfinder at the moment. So this lead that comes from here just comes to a fuse holder. and then this lead used to go straight into this 10-pin connector that ran power to the front. So this is, I was getting good 12 volts coming through here, but not getting the 12 volts as the front, as I was saying. So now I've actually come down, if you can see down here in the battery box, and just run a completely independent power lead that doesn't, that just runs in parallel essentially to this 10-pin loom. But another thing to point out that I was going to show you here is that this is quite often a fuse line. So if this fuse blows, you'll get this exact same symptom as well of just turn the key, absolutely nothing. Because when this fuse goes, no power is getting to the key, so no power is making it back to these other leads that activate the solenoid down the track. So this wire and this wire are actually connected by the ignition system. So if this fuse goes, that whole circuit's broken as well. So we've been through a few things that can go wrong. Now, one other thing that I'm kind of just want to cover generally is let's put the lean. There you go, that's better. It's my OCD. Is just general quality of connections. So if you see a voltage drop across a particular length of wire, so if you measure it and you're saying, you know, we're getting 12 volts here, but suddenly we're only getting 9, that happens because there's high resistance in that line. Voltage drops sort of in proportion to the resistance. So you want every connection to be as clean and tight as possible. So that's another big part of it, just clean connections. It takes quite a lot of current to get a starter motor turning properly. And that really means good voltage and low resistance to get good current flow. So make sure all your connections are good. The outside of these starter motors is the earth, so there'll be wherever this attaches. I think we showed before, sorry, I've done this video in many sections over many days, so I'm losing track of what's been shown. Hopefully it'll all come out in the edit. But you've got you need good earth to the body here, and then a good positive coming down to this point. So if all that's good, all your connections are good, you've tested all these other bits we've looked at so far, your starter motor's in trouble. Okay. One thing I will say actually is you'll hear these solenoids click. If you're hearing it click, if you're hearing your starter motor hum and nothing's turning, it's kind of worst case scenario, and that you may have a seized motor. That's the other situation you can possibly be in if you've got this no crank or no start situation where the motor's not turning over. If you're hearing a lot of humming from the motor, clicking from the solenoid, and the motor's still not turning over, it may actually be a seized motor. So that's another possibility. It's actually kind of the worst case scenario for this exact symptom I guess we're talking about. But presuming you're not hearing any of those, it's the starter motor not turning over. So the obvious choice, or the obvious next place to look at for that, is the brushes inside the motor. Because the motor turns and current needs to go to it, it has this, it can't have wires, the wires are just kind of wind up and snap, you know. So it has these brushes, and the brushes are essentially, so here's a smaller starter motor. This is from a little one, from a Yamaha 25 or something. This actually has a brush problem as well. So I've ordered a new set of brushes for this one, but it's actually missing one of these springs, so I'm going to have to hunt a spring down too. But the idea with the spring is that and so this brush is actually in reasonable condition. The other side's missing entirely. But the point is that they wear, so they rub against. I'll show you here. I'm actually going to take. So these little brushes rub against this outside part here. You'll see it's actually, wow, it's worn to a sort of a curve, and that's the curve that goes against here. And they supply current, and it's the spring that pushes the brush against here. So even as it wears, a gap doesn't emerge. The spring keeps pushing it in, so it makes good contact to the point where the brush is worn away. And when that fails, it doesn't matter how much current you get to these points, none's actually getting through the coil, so it's not turning. So what I'm going to do, this starter motor actually works. I think we might have shown that in a previous part of the video where I tested it was working, so that's good. But what I am going to do is take it apart anyway, just because this one's reasonably straightforward. So this has actually just got two brushes, one positive, one negative, whereas this one's got four. It's two positive, two negative, and they can be a little bit tricky to get together. So I thought it's a good opportunity just to check the quality of the condition of the contacts inside here, but also just to show you how to put it back together, because there is a bit of a trick to it. Okay, I'm not going to show you this because this screw, this threaded bolt is really tight into here, and I'm thinking it's going to snap, and I don't want to snap a bolt on a working starter motor and have this whole headache that I've got to solve that I actually caused. I think rule one of mechanics is just don't cause harm. You know, it's one thing to fix things, just wherever possible avoid causing more damage. So what I'm going to go show you though is, I'll show it to you in theory, and when I get another starter motor of this design I'll show you. So where we had this one and the brushes came in and the spindle rotated and they press this way, with a motor like this there's four but they all point upwards, so they actually, instead of coming into the side here, they actually push upwards onto the bottom of the spindle here. So very similar idea, except instead of having two from the side, you've got four coming up underneath. Now the thing about that is the springs are pushing them up and they push right out of their little guides, little sliding parts that hold them in. So what you do is, there's a tool, but of course I don't have one of those either, so I just got a bit of stainless steel and cut a groove. I might actually take the other end of this and cut a slightly narrower groove, depending on the size of starter motor you're working on. But the technique is that you have this bottom plate, you've got all your brushes pointing upwards, and you use this plate to hold them in, so the springs are trying to push up, and then what it allows you to do is get this spindle down into it, and then once you've got this holding them down, you can pull this plate out and those springs will push up, and then you can put these bolts in and tighten it all back together. That's the technique. Sorry I can't show it to you. I mean, I maybe could, but I just don't want to take the risk of snapping that bolt. It's a pretty old starter motor. So this really is what you need, this kind of just a groove. This groove is just designed to go around, so it can be maybe a bit narrower than that. This works okay for starter motors that size. I might actually do a smaller groove here, but put it in, you're holding those springs down until you get this on, and then you can slide it out. So if ever you got that this style of starter motor with the four brushes pointing upwards, make sure you make yourself something like that, just a thin bit of metal, like a fork type arrangement. Otherwise you'll never get those brushes to stay in while you put it back together. So that's that. A few other things I'll say. So here you'll see this brush, there's an insulating material here. This brush is attached to the positive, whereas this brush is attached just straight to the casing, so that's your negative and your positive. In this case you have something very similar, except there's two positive and two negative. The last thing I'll say about starter motors is often people give them a bit of a hit because the brushes stick, they've worn, the springs are out, it's wagging back together. But they've got these solid core magnets inside them. You'll see here, these are the magnets. They're very strong magnets. These if you hit it with a hammer you can just break those, alright? So yeah, it's kind of a neat trick. Take a starter motor that's not going, you hit it with a hammer, it starts, everyone thinks it's wonderful, but it's really not the way to go, okay? If it's not starting, there's a problem with the brushes. They're either too worn, the spring's sticky, get in there, clean out some of the old brush that's worn away. It'll be in there as like a sort of powder, sort of like a carbony sort of powder. If you just keep hitting it with a hammer, you're going to break it, then you're going to have to another $500 starter motor. So try to avoid doing that in anything other than a real emergency. Yeah, it's a trick that can work. It won't start, hit it, goes, you're stuck out at sea, you're going to save your life, whatever, go for it. But don't use it as a sort of a matter of course way of just getting a motor going. Just fix it properly. So I think we've covered now pretty much everything can go wrong. yeah, sorry I couldn't show you this one, but the idea is very similar. It's just brushes against springs. And then if it's not cranking, well, you've missed something, because that's pretty much all the components there are to a starting. So I guess just sort of quickly go over them again. Just firstly, check that it's in neutral. Check the battery's charged. Check that all your connections are clean and tight, because otherwise current drop doesn't work. If it's in neutral and your sort of neutral switch that detects that is faulty, it doesn't close, it's not going to start. One thing I don't think I mentioned is the actual ignition switch. So I talked about in my boat I didn't have good voltage coming to the ignition switch, but when you turn the switch to ignition on and then to start, check that it's coming out. If that's not happening, faulty ignition switch. That's not a problem you can have. Sorry, I don't think I covered that. And then when current does make it all the way back to the solenoid, check the solenoid's clicking, that it's activating, it's sending the main current through. If it's getting through, the starter motor's not starting, it's probably the brushes and the starter motor itself. So let's sort of go from battery through to switches, in-start protection through to starter motor. That's pretty much the entire flow. And you saw the circuit diagram before from the manual as well. So I hope this helps you if you're having this problem. If you're having this problem and you can't solve it, feel free to leave some comments to try and help you through it. There's not too much to it, but it can be tricky. It took me a while to realise that it was the 12 volts not getting out on my boat yesterday to solve it. So an hour or so to diagnose it and 10 minutes to fix it. Hopefully, sometimes you're up for a replacement. Like I tried to replace to buy another switch. This is the in-start protection I showed you earlier for this boat. It turned out it was like a $90 part. So I'm going to try and see if I can fix this switch or find something a bit more generic as a replacement for it. So sometimes, all you realise there's a part that does need replacing and it can be expensive. That's life, I guess. So, so good luck. I hope you, if you do have this problem, you find it's something pretty simple like connection. You can get away without any money at all. So that'd be great. If this video is helpful for you and you want to see more like it, please subscribe, and I'll catch you next time. Thanks. Bye.